done today. This section is pretty easy. It's just some basic terms. If you saw this in geometry, that's great. So just a quick review. This section is 1.1. It's on angles and degree measure. And some basic concepts from geometry. 2 points can define what we have here is a line. Okay, anybody know what this is called? This is called a ray because it continues in one direction. And what's this? This is a segment. Okay, so we denote this as line AB. We'd put a line over it. This would be ray AB, and we'd start at A and go to B and put an arrow over the B because it continues in that direction. And this would just be AB. That's how we denote those. Okay, just a quick review from geometry. If you've got 3 points, then you can define an angle. Okay, now this angle usually is the small inside part. It's usually this guy right here. So we start with this side right here, end with this side right here. This is usually what we call the angle. Okay, now we use lots of Greek letters in this class. We use alpha, and we use beta, and we use gamma. This isn't what the book makes it look like, but that's my gamma. So this is a fish pointed sideways, and this is a fish pointing down, and that just looks like a funny looking B. Okay, that's what mine look like, but this is alpha, beta, and gamma. And you'll see those in the textbook. I think the one in the textbook looks kind of like that. Okay, that's a little bit better. But anyway, so we're going to talk about how we can label these because we want to make things consistent. So if we were looking at this angle right here, would we label it as ABC or BAC? CBA? CAB? Okay, angle A, angle B, or angle C. So, does this work? Why doesn't this one work? It's out of order, okay? This right here, that is the vertex, okay? That's got to be in the middle. So we've got to do BAC or CAB. So BAC works, okay? This one doesn't work because that's in the wrong order. CAB works, it's just going the other direction. Which of these can we use here? Okay, it's got to be angle A because we name it by the vertex. Any one of those three is okay, the other guys are not. Okay, now let's throw in some more vocabulary that you may or may not have heard before. So that's just a very basic angle. You've seen this type of notation before. If we look at this right here, this might be new. So we usually start with this side right here. We call this the initial side. Initial side, that's where we start. And then we call this one the terminal side. Okay? So initial is where we start, terminal is where we stop. This angle is labeled with the Greek letter alpha, so this would be angle alpha. So we could call this angle alpha. So again, there's alpha, there's the symbol, that's what it looks like. Here's beta, there's the symbol, there's what it looks like. And here's a legit one. Again, mine just kind of looks like this. Okay? So we use those Greek letters quite often. All right. So let's talk about this diagram right here. So we've got angle alpha here, angle beta here, and angle gamma here. Now this little m with the angle name inside of it represents the measure. So this literally means the measure of angle gamma. So this would be 80 degrees right here. This is the measure of angle beta. The measure of angle beta is 70 degrees. So we've got a little blank to fill in right here. What does angle alpha measure? It's got to be 30, okay? Because you all remember from geometry, there are 180 degrees in a straight line. So this is a straight line, 180 degrees over on this side. So if I've already used 150 of them, that means this one's got to be 30, so that's a 30-degree angle for the measure of angle alpha. Okay? Now, you're probably familiar with this already, but there are two standard ways to measure angles. Okay, one of them we use all the time. Everybody's familiar with these, and that would be degrees. Does anybody know what the other one is? Radians, very good. Okay, so radians. And we're going to use both of these. Radians, probably more than degrees. Okay, but we'll kind of go back and forth and we learn how to convert those. There's also something on a calculator called a grad. Okay, and we don't use those. I've never seen anybody use those. I know they use those occasionally over in Europe. and we might talk about those in just a little bit. So let's talk about what an acute angle is. An acute angle is an angle that measures what? Okay, so less than 90 degrees. Right angle is a 90-degree angle. Obtuse. Okay, more than or greater than 90. Okay? And what about a straight angle? Straight angle measures 180. Okay? Straight angle measures 180 degrees. Okay, now let's talk about something called standard position. Okay, here's standard position of an angle. It's an angle whose vertex is located at the origin with the initial side, so the starting side is on the positive side of the x-axis. So here's the initial side. So we've started with that right here. And I'm going to take this and I'm going to draw the terminal side. So let's say the terminal side ends right here. So this is the initial side. This is the terminal side. Okay? And this would be the angle right here. All right? So it says blank angles in standard position are measured in the counterclockwise direction. So starting here and going this way, so if we measure this angle right here, see how we're going in a counterclockwise direction? Anybody know? Positive. Very good. Okay, this is positive. Positive angles are measured starting at the positive side of the x-axis and going in a counterclockwise direction. And let's see, what if we go in a clockwise direction? Okay, those are pretty easy to figure out. Negative. All right? So let's say this one right here measures 50 degrees. How about this one right here that's the negative one that stops in exactly the same place? We've got this small 50-degree angle here. How about this big guy right here? That would be 310 degrees right here, and it would be negative because we went in a clockwise direction. So we'll talk about why that is in just a second, but let's kind of acquaint ourselves with how the plane normally looks here. So this is quadrant 1, quadrant 2, 3, and 4, something that you're all familiar with. If we start here and we mark off these angles, so we'd have 0 here, 90 here as we go counterclockwise, 180, 270, and what happens if we go all the way around? What would this be? This would be 360 degrees also. Okay? So that positive side of the x-axis would equal 360 degrees as well. Okay? So if we went a fourth of the way, this would be 45 degrees. Fourth of the way on the top half of the circle, I should say. Okay? If I went the other way, okay, so if I went counterclockwise, what would this be? Negative 45. Okay? It would be negative 45. Everybody good there? Okay, now that's just convention. That's just what everybody's used to. Can anybody think of a good reason why we'd have counterclockwise be positive? Because that seems a little weird. Counterclockwise, you'd think that would need to be negative. Anybody think of a good reason why we'd want counterclockwise to be positive?
Start in the positive direction of the y-axis.
I'll buy that. We start in the positive direction. So positive x and positive y. Okay, that's the main reason. Okay. Because if we do that, then in this first quadrant right here, the angle's positive, the x is positive, the y is positive, keeps everything nice and neat. Can anybody think of another reason? Yeah, Alexis?
I can't think of the sections that it's in, like section 1, 2, 3.
Excellent, I like that. So 0 to 90 is right here, okay? And that's quadrant 1, okay? It kind of goes with the first fourth of the circle or something like that. That might work. Okay. However you keep it straight, that's the way it is. Okay. I always say if you wanted to move to some Pacific island and convert who's ever there to your system, say you want to go clockwise and make that positive instead of the other way around, be my guest, but this is just standard throughout the world. Okay. So just something that you've got to get used to. Okay. So let's take a look at the bottom of the first page. It talks about something called coterminal angles. These are going to come up on the test. It says angles that have the same terminal side but have different measurements are what we call coterminal. So this is the definition of coterminal. So in other words, they end in the same place, but they have different measurements. So let's take this one right here. 50 degrees and negative 310 degrees. They both started right here. They ended in the same place, but we have different measurements for them. Okay, I could also do this. Let me give you another example. Let's take this one right here. Let's say this is 60 degrees right here. So I started here, went 60 degrees, stopped right there. Everybody agree that that's a 60-degree angle? Okay. What if I didn't stop right there? What if I continued going around the circle and went all the way around until I hit right there again? They both end in exactly that place. One of the measurements is 60 degrees. What's the other one if I went around the circle again? 420. Okay? So 420 would be coterminal. These two are coterminal. Okay? Now this idea that they're 360 degrees off from one another, okay, is this basic idea right here. Now this looks like an ugly formula, but here's what it means. The measure of angle beta is the same as the measure of angle alpha plus 360 degrees times some constant k. So k is any integer. Okay? We use that letter quite a bit. Any integer, positive or negative whole number including 0. Okay? So 315 and negative 45. Those two are coterminal. You can see that they're coterminal by doing this. So here's 315 degrees. There's 90, 180, 270. 360 would be right here. So this is 315 degrees. It's this guy right here. But that's also the same as negative 45. So you could either go around 315 degrees to get here or back up 45 degrees to get to the exact same place. So here's why they're the same. Because 315 is exactly the same as negative 45 plus 360 times 1. So let's see if we could come up with another one that would be coterminal with that. What if I did this? Negative 45 plus 360 times 2. So if I start at negative 45, let me just erase this so I've got a... So if that's negative 45, and that looks really awful, if I go one time around the circle, if I add 360 to that, that's 315. What does this 2 mean I'd do? Yeah, this is one time around the circle this way. Well, let's go twice. So let's add another 360 degrees. So if I add 360 to this, this is 675. So those are all coterminal. Okay, everybody okay with that? Okay, flip the page over if you would. You've got some assignment problems that are just like this. Find two positive and two negative angles that are coterminal with 45. So if I've got 45, so I'm starting right here, I can come up with two more positive ones by going around full circle again. So if I do add 360 once and add 360 twice, or add 720, this one's going to be 405. Everybody okay with that? This one's going to be 720 plus 45, so that's going to be 765. Is that okay? Or we could have just taken this one and added 360. Okay, that takes care of the positive ones. What about the two negative ones? Start with 45. Okay, and then we're going to add 360 times negative 1, or in essence, 45 minus 360 will give us 1. So that's going to be negative 315. And 45 minus, what am I going to subtract to go 2 times around the circle? 720. Okay, or subtract another 360 from this. This is going to be negative 665. Okay, so here are the two positive ones, and here are the two negative ones. Everybody good there? Okay, I'm going to flip the lights on for just a second. Can you still see okay? Yeah. All right. Okay, you do this problem exactly the same way. So you're going to take this and you're going to add 360, then add 360 again. That'll give you two positive ones. Then you're going to subtract 360 and subtract 360. That'll give you two more negative ones. Everybody okay with coterminal? Sure? Okay. All right, let's take a look at the next problem. Are these angles coterminal? Do they kind of look like they should be coterminal? Yeah, they kind of do. If you graph them, though, here's 8 degrees. Negative 368. Start here. 90, 180, 270, 360, and another 8 degrees. So this is 8 degrees. This is negative 368. Are they the same? No, they're not. And you can also tell because if I took negative 368 and I added 360, what would I get? I'd get negative 8 degrees. That's not the same as 8 degrees. That's negative 8 degrees. That's positive 8 degrees. So the answer there is nope, they're not. Okay? They look like they should be, but they're not. Okay, let's talk about the next type of problem that you're going to see. And we're going to go over just a couple minutes. I'll make it up to you, I promise. In fact, I can make it up to you big time even tomorrow. Okay? What's the smallest positive angle that's coterminal with these two right here? So here's what we do. This is a good thing to be in the practice of, or at least thinking about this. 400 degrees. Start at the positive side of the x-axis. 90, 180, 270, 360. How many degrees do I have left over? I've got 40. So I'm about right there. If this was 360, like you said, that would be 40 degrees left over. So that one right there, smallest positive angle that's coterminal, is 40 degrees. We got that by doing a picture. You can also do it this way. 400 degrees. Keep subtracting 360 until you get to the smallest positive angle you can. Okay. So that would give you 40 degrees also. All right. So let's take a look at this one right here. 1100 degrees. Okay, that's a little harder. Okay, let me give you a quick way to do this. Take 1100, subtract 360. Okay, that's not a very small positive angle, so let's subtract 360 again. 380. Subtract 360 again. That's going to be 20 degrees. Because 1100 is 360, 720, 1080, and 20 degrees more. That's what it looks like. We want to figure out that little sliver right there. We want the smallest positive coterminal angle with that. Any questions? Okay. That is the meat of the section. If you know how to do that, you're in good shape. There are a couple problems that require this information right here. Okay? So just real quickly, we're going to talk about this. I'm going to let you go plenty early tomorrow and hopefully on Friday too, right? Okay? So we'll just plow through this. Okay. One full circle has 360 degrees. Okay? But sometimes if you're dealing with a big enough surface or a big enough circle, degrees aren't very small. Even though there are 360 of them all the way around the circle, that's not a small enough measurement. So we break it down into something called minutes and seconds. So if I had this angle right here, 23.51 degrees, I could represent that with a decimal. It's a little bit more than 23.5 degrees, but it's also the same as this. 23 degrees, 30 minutes, that's what that one apostrophe type thing looks like. Okay, that's minutes, and 36 seconds. Okay, so 23 degrees, 30 minutes, and 36 seconds. So 1 degree is equal to 60 minutes. So it's kind of like hours, minutes, and seconds. Every minute is equal to 60 seconds. So this gives us our conversion factor, or conversion factors. And if you haven't been taught this, a conversion factor is just a funny looking one. Okay? 1 mile is 5,000, help me out here, 280 feet. If you have two things that are equal to each other, I can multiply by 1 mile over 5,280 feet to make a conversion. Okay, so here's what we want to do. We want to convert 35 degrees 15 minutes and 12 seconds into decimals. Everybody ready? Okay, so here's what we're going to do. Whoops, that's seconds. This is 12 seconds. How many seconds are there in a minute? Okay, so I'm going to take 12 and divide it by 60. As a decimal, what is that? Say 0.2. You're right, it's 0.2. Okay? So what we do is we then add it to this one. So this is going to be 35 degrees, 15.2 minutes. See how we got rid of the seconds? 12 seconds is the same as 0.2 of a minute, 1/5 of a minute. Now I want to get rid of this. So I'm going to take 15.2 and divide it by how many minutes in a degree? 60. Okay, grab your calculator. I want to do 15.2 divided by 60. And it says we're 2.5 with a 3 repeated. So that means we've got 35.25 3 repeating degrees. That's it. Okay, any questions? Okay, that's enough to get started. I do want you to read this section and get started on this. We'll finish up and deal with any questions tomorrow. I'm going to leave you with this. What would one degree be in seconds? It'd be 60 times 60, so 3,600 seconds. 3,600 seconds in a degree. Okay, have a great day. You've got a couple problems that are like this. We'll take a look at those tomorrow. If you have any questions, feel free to come up afterward.